Hi folks, let's solve longest palindromic substring. So it's a very typical dynamic programming questions, and it's a two-dimensional DP. Of course, it can be optimized to one-dimensional. So the problem is, given a string S returns the longest palindromic substring S. We can see in the first example, the longest palindromic substring can be BAB. It can also be ABA. In second example, it's BB. In third example, it's A. In fourth example, it's A. So let's take this example, S is BABD. I initialize a two-dimensional table. The size of each dimension is n is s dot length. And I also have two variables. The first variables record up to now the index of the longest palindromic substring. The maximum length is a length. Okay, table ij means if Sij is palindromic. For example, S02 is BAB, so S02 should be true when we calculate it. Initially, I set the value to a false for all the cells, and I only join the right part. For the left bottom part, it's not meaningful since an I is less or equal than J. For example, like S21, it's not meaningful. It's not a substring, so I ignore these cells. Okay, initially, we set table 0, 0, 1, 1, 2, 2, 3, 3, 4, 4 to true. Since one single character is also palindromic, so for this diagonal line, it's all set to true. Okay, next, we calculate this diagonal line, right? But since BAAB, BAAD, they are not same, so all of the cells are false. Okay, next, we need to calculate the substring whose length is 3. So they are S02, S13, S24. They are in this diagonal line. So we calculate the cells one line by one line. First, this diagonal line, then this line, then length 3, we calculate this line. So as long as, for example, for this cell, as long as S0 is same as S2, then the value can be passed from table 1, 1, right? So if S0 is S2, the value is passed from this cell. The value, so for this diagonal line, each of the cell, they may be passed from the left bottom cell as long as Si is same as Sj. So we find S0 is same as S2, S1 is same as S3. So table 02 and table 13, they can come from these cells. So they will be set to true. Table 24 is still false since S2 is B, S4 is D. They are not same. Okay, next, length is 4. We're calculating these cells. But for 0 and 3, for 1 and 4, the characters are not same, so they are all false. At last, length is 5. We're calculating table 04. Since S0 is not S4, so the value is still false. Okay, now I have all the values and I know the answers here. Let's take a look at the whole implementation. At first, we initialize our local variables. And in the first for loop, we set the diagonal cells. In the second for loop, we set these cells. Then here, we for loop length from length 3 to n. So we're calculating line by line here. First this line, then this line, finally this line. As long as an Si is Sj, the cells value will be passed from the left bottom cells. And we maintain the longest begin and maximum length in each for loop. And finally, we just return the substring, then we have the answer. So the time complexity is O(n) squared since we have a double for loop here. And the space complexity is also O(n) squared since we have a two-dimensional table here. But it can be optimized to O(n). We can see when calculating this line, they only used this line, which means when calculating cells whose lengths are 3, I only need to use length 1. When calculating length 5, I only need to use length 3. So when calculating length 7, I only need to use length 5. So I can calculate them first. Then I calculate length 2, then use length 2 to calculate length 4, then use length 4 to calculate length 6. So I can just maintain a one-dimensional table. So the space is better, but it's it's a little bit complicated to code. It's just like a normal DP problem. And in the interview, we can say it can be optimized to DP. The space can be optimized to DP. And then we can just show our ideas. Okay, and actually the time complexity can also be optimized to O(n). So it's a very smart algorithm, which is brought up in 1975. So it's miniature algorithms. If you are interested, you can search and you can implement it, but it's a little bit advanced. And so I will not discuss miniature algorithm in this video. If you're interested, you can learn yourself. Yeah, that's it. Thanks so much.